again, and welcome to this week's video for the 2020 Community Cloud Challenge, Science is Better Together. We appreciate the observations that are coming in, as well as all the other ways you are participating by engaging with, learning about, and creating with clouds. Please keep sharing with us using the Cloud Challenge hashtag, and visit our website, observer.globe.gov, for all the details. Hi, I'm Kristen Weaver, and I'm the Deputy Coordinator for the Globe Observer Project. Our science guest today is Patrick Taylor from NASA Langley Research Center. He's going to talk to us about the impacts of clouds on climate and how some clouds can have a cooling effect while others have a warming effect. And did you know that the Earth has a budget? Not a budget for money, but a budget for energy? If you didn't before, you'll learn about it today. After that, we have the pleasure of hearing from two experienced Globe educators, the mother and daughter duo of Joselyn and Wanda Hathaway, who will show us a hands-on way using simple materials to learn about cloud opacity, the thickness of clouds, a concept related to those different effects clouds can have on climate.
Our climate is changing. Over the last 130 years, the global mean surface temperature has warmed by more than 1 degree Celsius, which is more than 1.8 degrees Fahrenheit. Clouds have influenced how much the Earth has warmed over this time, but it is unclear by exactly how much. More on clouds in a few minutes. On this animation, warming is illustrated by the increasingly red color across the planet. While 1.8 degrees Fahrenheit may feel small, this amount of temperature change is a big deal at the planetary scale. It's actually more than 5 times larger than what we would expect from natural changes in temperature that we see from one year to the next. More striking is that the 20 warmest years on record have all occurred in the last 22 years, since 1998. This means that a 22-year-old and a 100-year-old have both lived through the 20 warmest years in the modern record. This warming across the planet is happening because of the increase in carbon dioxide in the atmosphere. The increase in carbon dioxide is a direct result of human activities and primarily the burning of fossil fuels. My name is Patrick Taylor, and I'm a climate scientist at NASA Langley Research Center. My research aims to understand how energy flows across our planet, and in particular, how clouds influence the flow of energy. I'm also a member of the Clouds and Earth's Radiant Energy Science Team. We call it the CERES project for short. CERES is the only project worldwide whose prime objective is to produce global climate data records of Earth's radiation budget in clouds over many decades. CERES does this from space by using 6 CERES instruments on 4 different satellites. For most of our Earth science research at NASA, we use satellite data. This animation shows our Earth observing fleet. It is comprised of more than 20 different satellites. You may be wondering why there are so many. I like to think of Earth's climate as a puzzle, where the pieces of the puzzle are the atmosphere, ocean, land, plants, animals, ice, and humans. No single instrument or mission can observe all pieces of this puzzle, so we need many satellites to see the whole picture. The CERES and MODIS instruments are specially designed to observe and study Earth's radiation budget in clouds. These instruments are located on satellites that are found in sun-synchronous polar low Earth orbit. This means that these satellites observe the entire globe twice a day and always at the same time of day. In order to be in this orbit, these satellites are placed at an altitude of 440 miles above the Earth's surface. This is much closer to the Earth than geostationary weather satellites are. Geostationary satellites are found about 22,000 miles above the Earth's surface. From that far away, it's much harder to see the detailed features of clouds. Low Earth orbiting satellites provide a much closer look and resolve the finer details, which are important to understanding just how clouds work. As I mentioned before, the CERES project observed Earth's energy budget. Earth's energy budget is determined by the amount of sunlight that's absorbed by Earth and the amount of infrared energy emitted to space. Earth's energy budget is important for climate because the difference between these two energy fluxes controls Earth's temperature. I like to think of energy as the money of the climate system. Just like you cannot buy or sell something without money changing hands, the temperature cannot change and it doesn't rain unless energy moves from place to place. When there's more infrared energy lost to space than sunlight absorbed, Earth's temperature drops. When there's more sunlight absorbed than infrared energy lost to space, Earth's temperature rises, like it is now. Right now, the increasing amount of carbon dioxide in the atmosphere is keeping the infrared energy that was once lost to space trapped inside the Earth system, causing it to warm. This animation shows CERES data that has been collected showing how and where Earth cools by losing infrared energy to space. The regions in the oranges and bright yellow colors are losing the most energy to space. These tend to be the warmest places and are especially in desert regions. The purple and white colors show places where there is much less energy lost to space. These places are colder, so they tend to be the Arctic and Antarctic, but are also places with lots of clouds, like the Amazon, Central Africa, and the tropical Western Pacific region. The next animation shows series observations of reflected sunlight from the Earth. The blue colors show you regions of the world that reflect little sunlight back to space. These are primarily found over the oceans. The green and bright white colors show you places on the planet that reflect a lot of sunlight to space. These are the polar regions, which are covered by lots of bright white ice and snow, as well as some places in the tropics that have lots of clouds. So it's interesting that in both of these cases I brought up clouds. You may have also noticed that the first letter in the series acronym stands for clouds. Clouds are an important part of Earth's climate, not just because they rain, but because they change Earth's energy budget. Clouds reflect sunlight back to space, which cools the planet. You can feel this effect on your skin on a hot day when a cloud comes overhead and momentarily blocks the sunlight. Your skin immediately feels cooler. Clouds also reduce the amount of infrared energy lost to space. This warms the planet. This is because clouds are found in the atmosphere above the surface, which has a colder temperature than the surface. So clouds can either have a cooling effect or a warming effect. Whether clouds warm or cool the surface depends on their height and the amount of water that they contain. In general, high clouds tend to have a warming effect, and low clouds tend to have a cooling effect. The series data shows us that not all clouds are created equal. And from this animation, we can see that the effect of clouds is different across the Earth. The greenish and blue colors show you places where clouds have a cooling effect. This is generally found over regions of the ocean where there are lots of low clouds which reflect a lot of sunlight. Places that have higher clouds reduce the amount of infrared energy lost to space and warm the planet. The yellow colors in this animation are found primarily over land and in the polar regions, showing that clouds have a warming effect there. The total effect of clouds on the planet is to be a cooling effect. In sum, Earth's energy budget and the role that clouds play in it are very important to our climate system and are a very active area of research. Clouds around the planet are responding to the increasing temperatures, and clouds in different regions are changing differently. There are some regions where clouds are happening less frequently, other regions where cloud tops are getting higher, and yet other regions where the amount of liquid water in the clouds is getting larger. Exactly how clouds change and how these changes influence Earth's energy budget over the coming decades will have a strong influence on how much and how fast our climate changes. Understanding how clouds influence the flows of energy around the planet is critical to determining our climate future, meaning how clouds change affect how hot and dry summers will become, the frequency of extreme weather events, and also where it rains, when it rains, and how hard it rains. At NASA, we're using satellite data to try to get to the bottom of this so that society can thrive on this changing planet.
My name is Joselyn Hathaway. I'm a math teacher for River Road Middle School.
Hi, my name is Wanda Hathaway, and I'm a teacher at Churchland Middle School, and I'm a science teacher.
I've been a NASA intern.
And I've been a teacher intern.
So we are home during COVID following the safe guidelines, and we encourage you to do the same for this activity. So for today, we're talking about opacity. So what is opacity? Opacity is a lack of transparency. So for this activity, we're looking at transparent, translucent, and opaque. So let's talk about transparent. Transparent is talking about how you can see directly through. So let's say you took a light source and you turn this on. If you were to stick this light behind the plastic wrap, you can see the light directly through it. So that means it's very see-through, very transparent. If you have wax paper, it's a little bit cloudier. So if you take your light source and you stick your light behind there, you can still see the light, but it's a little bit cloudy. And our last source is aluminum foil, or our last material is aluminum foil. So if you put that light behind it, you can't see it at all. So that would be opaque. So remember that definition: lack of transparency, opacity, opaque.
What I want to do is to show you the connection between opacity and clouds. Clouds, we see them all the time outside when we go out and we're playing, of course, being safe in the COVID guidelines. Clouds are there for a good reason. Clouds help us to keep moisture, get us moisture to the earth, and it also helps to protect us from different types of other elements and different types of harmful rays. But to show you the difference between the clouds and then to show you the relationship between opacity, we have three different types of clouds. We have the cirrus clouds, the altocumulus clouds, and cumulus clouds. Now, most times you'll see cirrus clouds when it's a really pretty day, a lot of times during the summertime right now. But cirrus clouds tend to be very, very clear. They're the wispy type of clouds. And those clouds tend to be very friendly with the light. It lets lots of light come through because there's not a lot of clouds, there's not a lot of water droplets, there's not a lot of particulates, and we call them particles. Could be dirt particles, could be ice crystals that would block the sunlight from coming through. That's why when Ms. Hathaway took the light and put it behind the translucent or the plastic wrap, it went through with no problem. When we talk about the altocumulus have a little bit more clouds. This is kind of like your overcast day. It's not really a dark day, it's not really super bright, but it is a overcast day where some sunlight can get through, but you have some clouds and you have some possible water droplets again, where sunlight reflects off of the water droplets as well as ice crystals. Therefore, it slows down the penetration and the flow of the light coming through, as when we saw the light behind the wax paper. When we talk about cumulus clouds usually are telling us that a storm is approaching of some sort. We might not know exactly what type of storm, but we know one is approaching. Notice the difference between the cumulus cloud and the altocumulus. They're bunched up together, puffy clouds, but they're dark as well. And that darkness is telling us there's lots of debris or particles, those particulates we talked about. They're in the clouds, so therefore sunlight has a really difficult time of getting through. So that was when we took the light, when Ms. Hathaway took the light and put it behind the aluminum foil, and no light could get through at all. So there's a close relationship between cirrus, altocumulus, and cumulus clouds when we talk about opacity, the ability for light to penetrate or to travel through some type of medium. And in our case, these medium would be the different types of clouds.
And you can do the same activity at home with your family and make sure that you're staying safe when you do this and that you social distance if you're outside.
Thanks so much to Patrick, Joselyn, and Wanda. I love seeing the connections between the science and research topics and the ways we can teach and learn about them through simple activities. And I have to say, Cloud Clues is one of my personal favorite clouds activities to do with kids. Well, thanks for joining us today, and stay tuned for next time. Until then, remember, science is better together.